So when we're talking about exponents, right? There's two parts to exponents. There's the base. The base is the big part. So like this guy right here, 3 is the base, right? And then the little number, right, is the exponent. Sometimes it's called a power, right? That's what exponents are, right? When it has that little number up top. The big number is called the base though. Could be a number, could be a letter, whatever it is. So 3 to the 5th power. 3 to the 5th power means, right? 3 times 3 times 3 times 3, 5 times, right? So the expanded form is just what it is. All right, that's what it means. 3 to the 5th, that's what it means, right? So we can put equals. Numerical representation is what the answer actually is. If I were to go to my calculator and say 3 times 3 times 3 times 3 times 3, that's what I would. So if I said 3 times 3 times 3, or 3 to the 5th power, right, is 243. Okay. The next one, there's 2, 4, 6, 8 2's. So we say 2 is the base, 8 is the exponent. So if we multiply all of those guys, we get 256. Right? So 81. If 81 is the numerical or numeric representation, what would the exponential be? 9. How many ninths? You're right, 9. Not to the 9th power. Squared, right? Because it'd just be times itself. There's actually another one. That's 1. That works. 9 squared makes 81, right? There's actually another one. It's 3 to the 4th power. 3 times 3 times 3 times 3. If I did those, 3 times 3 times 3 times 3, you'd also get 81. So either one of those works. Okay. 5 to the 4th. 5 times 5 times 5 times 5, which is 625. 4 to the 3rd, right, which is 64. Okay. So that's what they mean, right? That's what exponents mean. Now we're going to get to more of the rules. So one of the rules we're going to use this table for. So 4 to the 3rd, right? You notice, look at the pattern here, right? The pattern here, the base is all the same, right? 4 is the big number. It's always going to be the big number here. The powers are either going down by 1 or going up by 1, depends on how you look. If you go this way, it's going up, right? There's a pattern, right? Okay, so 4 to the 3rd. We just did that one, right? 4 to the 3rd is 4 times 4 times 4, right? Which is 64. Okay. 4 squared means 4 times 4, right? Which is 16. What does 4 to the 1st power mean? Yeah, 4 times 1 or just 4 by itself, right? If you look at the pattern here, aren't I losing a 4 every time? So that means I just have 1 4. It is 4 times 1, you're right. It is 4 times 1, so it's just 4. Okay? Pretty good there. You guys know how to do that. But 0, this is where we start getting different answers. So 4 to the 0 power, right? So there's a pattern there, right? 3rd power, 2nd power, 1st power, 0 power. There should be a pattern over here too. Over here in the middle, we're losing a 4 every time, right? So my question is, what's going to go here? Could be 0. Does anyone else think anything differently? Could be 1. Some people, that's usually the answers I get. 0 and 1, right? Which one is it? Well, let's look at the pattern. Has to fit the pattern. To get from 64 to 16, what do I do? Close, not square root. Well, let's do, how do I get from 16 to 4? Divide by 4, right? Do I do the same thing for up here? 64 divided by 4, right? That's the pattern. So the pattern should stay the same. So what's 4 divided by 4? 1. So actually, 4 to the 0 power is just 1. In fact, anything to the power of 0 is always going to be 1. It doesn't matter what it is. You see a 0 power, change it to 1. Always. That's just the way it is. Okay? So, -1. Now we go to the negatives, right? We're getting to the negatives now. -1 power. Same rules, right? It's the same rules. So, I get this answer a lot. 4 to the -1 is -4. Well, does it fit the pattern? My question is, does it fit the pattern? If I were to divide 1 into 4 pieces, how much would I have? Or 1/4, right? 0.25 or 1/4. And if I were to divide like if I have 1 out of 4, and if I were to divide that into 4, I'd have 1 over 16. Half of that, right? Or sorry, quarter of that. 0.0625, I think it is, or 1/16. Okay, so as I go down, 64, 16, 4, 1, 1/4, 1/16, what's happening to the value? Is it going up or going down? It's going down, right? It's getting smaller and smaller and smaller. That's what happens. That's what negative exponents do. Okay? That's what negative exponents do. They don't make it negative. They don't change your answer to negative. I can't tell you how many times I've had students say, if I ask them, what is 4 to the -2 power? And they say, oh, -16. No, it's not -16. It does, powers, exponents do not make an answer negative. Okay? They just make an answer either really big or really small, right? 4 to the -2 is 1 over 16. That's really small. But 4 to the second power is regular 16, right? So it's making it bigger. So what's the trick? Well, the trick is if you have a negative exponent, what we do is if it's on top, we move it to the bottom. So these guys are on top. How do we know they're on top? Because they don't have a bottom, right? 1 is the bottom. So we move them to the bottom and they become positive. So 4 to the first power is just 4. 4 to the second power is 16. That's why they become fractions. That's how we deal with negative exponents. If they're on top, we move them to the bottom. They become positive. Their powers become positive. If they're, what about this? What if it's already negative on the bottom? What do you think I'm going to do to make it positive? Move it to the top. So this is another way of saying this, which is 16, right? It's another way of saying that. Okay. So that's part of our rules. That's one of our new rules. One of our new rules that you guys, we haven't done in this class. You might have done it in math too, but you've never done it. I think they even do it in junior high now, negative exponents. But we've never talked about it in this class. Okay? So negative exponents do not make the answer negative. They just make the answer really small. Okay? Like if I had 4 to the -3, right? That would change to 1 over 4 to the third, which is 1 over 64. Okay, that's how you deal with negative exponents. So the rules, I put the rules up here. The rules are on the board. If you have two bases that are the same, two bases that are the same. Oops. Nope. What am I doing here? Right. If I have bases that are the same, I add their exponents. Okay. If I have here, I have one base, but it's got two powers, right? It's a power to a power. So I multiply their powers. Negative exponents, right? Negative exponents, dealt with those. Anything to the 0 power makes a 1. If I have a base on top and a base on bottom that are exactly the same, I subtract their powers. Okay? Here, x, y, they're both to the power of a. So what do? I give them each a power. I say you get a power and you get a power and multiply. Okay? And then here I have division, right? It's division or a fraction. What do? How do I give powers to a fraction? Well, the top gets an A, the bottom gets an A. They both get an A, still a fraction. Okay? Those are the rules we're going to use today. Those are the 7 rules we're going to use today. We just have to decide when to use them. Okay? That's kind of the hard part, is when do I use this rule? When do I use this rule? When do I use that rule? Okay? Okay, so, oops, go back here. Okay, so here we go. Let's go to the back, or the inside. You're going to see the word simplify a lot. Simplify exponents. Simplify, simplify. What does that mean? Well, when you have exponents, it means you can't have any of these guys. So our finished answer can't have negative exponents. If we have negative exponents, we have to change them. Move them to the top, move them to the bottom. We can't have any bases that are the same, like bases. If they're like bases, we either have to use one of these two rules here to combine them, to combine their powers, right? No 0 exponents. We can't have any 0 exponents. What happens if we get a 0 exponent? Change it to a positive 1. No parentheses. When you're done, when your answer is done, you can't have any parentheses left. Okay? Once you do all of those, your answer is already done. All right? Okay, so let's look at example 1a. In math, we always start with parentheses. So if there's parentheses, deal with that. We don't have any parentheses here, right? On 1a. So skip that step. The next one is negative exponents. Do we have any negative exponents? We do, right? I have a negative exponent. This guy and this guy both have a negative exponent, right? How do I make them positive? Move it to the top. Yeah, so what I'm going to do is move those guys to the top. This guy is going to move up here. This guy is going to move up here. What about the X that's already on there? Does that guy need to move? The X that's already on top. Does that guy need to go anywhere? Does he have a negative exponent? No, so he can stay. Okay. So the X that was already on top can stay. Doesn't have a power though. What power does it have if it's not there? Not 0, 1. 1, yeah. Okay. X squared, negative 2 moves to the top and becomes x to the positive 2. And then same thing with this guy over here. Nothing left on the bottom. So if there's nothing left on the fraction, there's always a 1. Good. So now I have no negatives, I have no parentheses, but I do have some like bases, right? I have x to the first times x to the second times x to the first. What do I do with their powers? I can combine them. What do I do with their powers? Yep, that's step one, right? Or rule number one, add them. So when I add them, I get x to the fourth. Since it's just a 1 on the bottom, you don't need to write that one. It's not wrong, but you don't need to write it. You're done. Okay. Let's look at 1b. 1b. So now I have another letter, another base, not just all x's, right? Some y's in there. So I'm going to color code them so that I know which bases are the same. Remember, if something doesn't have a power, its power is always 1. So I'm going to give that guy a 1. Parentheses. Do I have any parentheses? Nope. So move to negatives. Do I have any negatives? Yeah, I have a few, right? So what I'm going to do is I'm going to take this guy here. It's got a negative exponent. That guy's going to have to move down. This guy right here is going to have to move down. Everything else can stay because it doesn't have a negative exponent. The y on top doesn't have a negative exponent. The x to the third on bottom doesn't have a negative exponent, right? So those can stay. Okay, so like what happens? What does it look like when those things move? Let's see. So on top, I'm just going to have a y to the first, right? On bottom, I'm going to have several things. I'm going to have x to the first, x to the third, y to the first. Okay. So here are the y's, here are the x's. Okay. I have two x's that are side by side. So the two x's that are side by side in green, what do I do with their powers? Add them up. So we get x to the fourth, right? But I also have two others that are the same y bases, right? Their powers are 1 and 1. What do I do with those powers? What do I do with the y powers? I'm not going to add them, right? Because they're not side by side. I'm going to not divide them. You're close. You're going to, right here, number 5. Subtract them. Subtract the powers, right? So when I subtract the powers, what do I get? 0. Y to the 0. Anything to the 0 power is equal to 1. So that's what's left on top, 1. You are done. Okay. All right, so let's move to number 2, 2A. Let's start with 2A. Yeah.
Why'd you put 1 on the top? If there was a y on both the top and the bottom.
You could put a y on the 1 on the bottom too. Wouldn't change the answer, right? Okay. You could do that. It's not wrong. I just needed 1 on top because there was nothing there. But you can put a 1 on top and 1 on bottom. It's not wrong.
So if the answer could be 1x to the fourth power.
Say it again. 1 over.
No, could the answer be 1x to the fourth power, or does it have to be a fraction?
Has to be a fraction because the x's were on the bottom, right? So the x's were on the bottom. If they were on top, they could be on top. But because these guys here were on bottom, I have to keep them on bottom. That's why they have to be on the bottom, yeah. Okay. All right, so number 2 now. Number 2. Okay, we have to simplify again. Can't have any negatives, can't have any parentheses, can't have any 0 exponents, none of those. When I say negatives, I mean negative exponents. Okay, I don't mean negative big numbers. Negative bases are different. Negative exponents. Okay, so I have parentheses. What do my rules say when I have parentheses? Something, two things, right? I have a negative 4 times x. They're both squared. What do my rules say? Which rule does that going to be? Number 6, yeah, rule number 6, right? -4 times x to a power, right? And what does the rule say? Give them both that power. That's what I'm going to do. Okay, so I'm going to give them both that power. So -4 is going to get a -2 power. X is going to get a -2 power. What's on bottom? 1. I'm going to need a bottom on this one, right? So negative exponents, move this guy to the bottom, move this guy to the bottom. There's only a 1 left on top. On bottom, I get -4 becomes a +2, right? And x to the +2 because I moved them. Okay. My last thing is, what is -4 squared? It's a number.
16.
It's 16, right? I get some people saying 16, some people say -16. Your calculator's even confused. I'll show you. -4 squared is -16. -4 in parentheses is 16. What's they're both the same, right? Why is one giving me a negative answer and one giving me a positive answer? The answer is your calculator knows PEMDAS way too well, right? Your calculator, because I have a lot of people who put the top one in their calculator. Oh, okay, -4 times itself. But your calculator is very literal, right? Literal means you have to explain it. There are people that you can't joke around with them, right? You're just like, you have to be very literal because they don't, it's the same thing with your calculator. Your calculator is very literal. You have to explain it very, very carefully. You want your calculator only to multiply this number to this power. That's the one with the parentheses, right? Because -1, because the top is really this. That's what this means. And if your calculator does that, it's going to say, oh, 4 squared is 16 times 1, -1 is -16, which is right. But you're like, I don't want that. I want you to take -4 and multiply it by itself. -4 times -4 makes +16. That's the answer I want. So be careful when you're using your calculator. Sometimes you need to use parentheses. Okay? Okay, so -4 times -4 is +16. So we get 16x squared. No more negative exponents, no more 0 exponents, no more parentheses. That's when you know we're done. Okay. All right, let's look at B now. 2B. Parentheses, 2B. 2B does not have any parentheses, right? 1 second. Okay, so no parentheses, right? 2B has no parentheses, but it does have a negative exponent, right? Question is, who gets that -1? Whose exponent is that -1? Is it both -5 and x, or is it just x? Whose power is -1? It's just x, right? If I wanted them both to have that power, there would be parentheses there, right? But I don't want both. I just want the x to have that power. So to make that positive, what do I have to do? Move it to the bottom. Here's another thing I get. Don't we have to move -5 to the bottom too? Because it's a negative. No, because it doesn't have a negative exponent. That's the only guy that matters, the exponent. If it has a negative exponent, move it. If it doesn't have a negative exponent, leave it where it was. Okay? And you're done here. Okay? All right. Okay, so the example 3, the last 4 examples, these are the last ones we'll do. I'm going to go very slow. Take it step by step because I don't want to mess up on a step. The hardest part about these guys is going slow because sometimes you try to do it too fast and you get stuck and you're like, what am I doing? So for these guys, for the last 4 problems, I'm going to go very slow. Might be too slow for you. If it's too slow, you don't have to wait for me. But I'm going to go really slow because it helps. Okay, so again, simplest form, only positive exponents. So the first thing we got to do is parentheses. If we have parentheses, deal with the parentheses. Okay. So we have this guy in here, right? -3 and q to the -3. Those are in parentheses, right? Well, what does the rule tell us? What does the rule tell us if we have that situation? Both should get a exponent, right? So that's what we're going to do. -3 is going to get an exponent of 3. Q to the -3 is going to get an exponent of 3. The bottom, I'm not going to change. I'm not there yet. I'm just going to rewrite it -6 q to the -6. Okay. All right. So -3 to the 3rd power means -3 times -3 times -3, right? So we go negative, I'm going to use parentheses, -3, parentheses, and I want to the 3rd power. I get -27. Okay. How do I deal with this guy? Q to the -3 to the 3rd power. What do I do with the powers? Which rule am I going to use? Multiply. It's rule 2, right? Rule 2 says if you have a power to a power, multiply them. So I get q to the -9 power. No more parentheses. Okay. The next thing I need to worry about is negative exponents. This guy, q to the -9, has a negative exponent. That means it's got to move down. This q to the -6 that's already down has a negative exponent. It's got to move up. So let me rewrite what I have. Q to the -6 moves to the top to become q to the +6. Q to the -9 move to the bottom to become q to the regular 9. Okay. Q to the 6 on top, q to the 9 on bottom. These guys have like bases. What do I do with their exponents? Which rule is that going to follow right there? It's going to follow rule 5, right? Rule 5. Rule 5 says, what do I do with the powers? Subtract them. Good. So when I subtract 6 minus 9, I get 3 left over, right? Where are the 3 going to be? Left over on the bottom or left over on the top? On the bottom. So that means I'm going to have q to the positive 3 on the bottom, since that's where they're going to be left over. Okay. Negative 27 and negative 6, those are regular numbers. Can I simplify those? Negative 27 and negative 6? I can divide them both by what? What's the GCF biggest number that goes into both? Negative 3. They're both negative, so I'll divide them by negative 3. So when I divide them by negative 3, I get positive 9 on top and positive 2 on the bottom. Okay, then you're done. All right. All right, so let's do B together. Okay, same thing. Start with parentheses. If it has parentheses, deal with the parentheses first. So the parentheses, the stuff on the inside is squared. The stuff on the inside is squared. So that means everything on the inside gets a squared, a second power. That's what the rule says. So I have negative 3 squared, b to the 4th squared. Okay. All right. Finish off the parentheses. Negative 3 squared. Negative 3 squared is negative 3 times negative 3, which is positive 9. What do I do with the powers of b? B to the 4th squared. What do I do with those powers? Multiply them. Good. So I get b to the 8th. Okay. No more parentheses. Negatives. Well, I do have a negative down here that I need to move up. So I have 9 times b to the 8th, and then I have a b that moves up, so it becomes b to the 9th on top. Negative 12 stays on bottom because negative 12 doesn't have a negative exponent. Bases. Do I have any like bases? I do have like bases, right? I have b and a b. What am I going to do with those powers? 8 and 9. What am I going to do with those powers? Add them together. Good. So I get 9 b to the 17th negative 12. So right now I'm at almost there. This is like a 3 out of 4 on a test. If this was a test problem, quiz problem, you'd get a 3 out of 4. Almost there. What's the one thing that I need to do that's left? Simplify, yeah, reduce. 9 and negative 12. What's the biggest number that goes into 9 and negative 12? 3. So divide them both by 3. You get 3 there and negative 4 there. So your finished answer is going to be 3 times b to the 17th over negative 4. Okay. All right. Let's do 2 more, we'll be done. These 2, and then we'll be done. We'll do more practice tomorrow. But for today, we'll be done with these 2. Okay. So letter C now. Parentheses first. parentheses first. Okay? The bottom has parentheses. The top does not have parentheses, so I'm just going to rewrite the top. The top is not where my first step is going to be. Everything on the inside of the parentheses. I have a 3, I have an r to the negative 3, and I have a c. They're each going to get a power of negative 5. Okay, so I have positive 3 to the negative 5 power. I have r to the negative 3 to the negative 5 power. And I have c to the negative 5 power. Okay. Get rid of the parentheses. Let's see. So on top, I have 15. I don't have anything parentheses on top, so I'm just going to rewrite it. On bottom, I have 3 to the negative 5. That's just 3 to the negative 5. But r, I have negative 3 power to the negative 5 power. What do I do with those powers? Multiply them. So if I multiply them, I get r to the 15th power. Positive 15, because negative times negative makes positive 15. And then c is just going to be c to the negative 5. Okay, parentheses are all done now. Move to negative exponents. Everything that has a negative, I'm going to circle and put an arrow with it. Okay. So on top now, I'm going to have 15 times r to the 6th, and then the c to the 5th is going to move up because I had a negative and it was on the bottom. Oh, sorry, I forgot one too. The 3 to the negative 5 becomes 3 to the 5th power. And then I have two things on the bottom. R to the 15th and c to the positive 8 now. Those are the things that moved around. Okay. No more negative exponents. Everything's positive now, right? Okay, so now let me use my rules. So I got R's here and I got C's here. R on top, R on bottom. What do I do with those powers? Subtract them. I'm going to have how many left over when I subtract them? I'm going to have 9, right? Where are those 9 going to be for R? Are they going to be on top or are they going to be on bottom left over? Bottom, right? 15 is bigger than, so it's R to the 9th power. C, same thing. I'm going to subtract 5 and 8. 5 minus 8 is 3 or negative 3. Where are the 3 going to be left over, on top or on bottom? Bottom, good. Okay, the only last step you need to do is multiply. What is 3 to the 5th and multiply it times 15? Because those are numbers. We can multiply those. So 3 to the 5th is 243 times 15 is 3,645. 3,645. That's what's going to be on top. 3,645. R to the ninth, C to the third. Okay. Try letter D on your own. We'll do it together, but I want you to try it. I'm pretty sure you guys will be able to do it. Okay. So try that one on your own. Okay, so parentheses. W, the only thing in the parentheses is W to the fourth. That's the only thing in the parentheses, right? So I'm going to have to give that one a -1. The -3 in the front is not inside the parentheses. So I'm not worried about giving that guy a -1. So W to the fourth to the -1. What do I do with these powers here? Multiply them. Yep. So I get -3 times W to the -4. And on bottom, I get 5 times J to the -6, right? Parentheses gone. Negative exponents next. So I have -3, that stays. Now it's going to be with J to the +6, right? 5 stays on bottom, and it's going to be with W to the 4th power. You're done. That's just, J and W are not like bases. These guys are not like bases. They're not the same. So you can't subtract 6 minus 4. You're done. Okay. All right. So what I want you to do is tape into your notes. There should be some tape in the back. If not, I have a tape on my podium here. There's a tape right on top right there. You take that.